To solve applications of quadratic equations, we will use the same steps we have used for solving other types of application problems. First, we define variables to represent the unknowns of the problem. Next, we translate the problem into an equation. Then we solve the equation. And finally, we use the solution of the equation to clearly answer the questions posed in the word problem, remembering to label our answers with the appropriate units. Let's look at some examples of problems involving area that can be solved using quadratic equations. The length of a rectangle is 3 centimeters more than the width. If the area of the rectangle is 108 square centimeters, find the dimensions of the rectangle. Round to the nearest tenth if necessary. To begin this problem, it may be helpful to draw a quick diagram. We can show a rectangle that has an area of 108 square centimeters. And we're told that the length of the rectangle is 3 centimeters more than the width. So we can define our variables as follows. If we let W equal the width of the rectangle in centimeters, then 3 centimeters more than that would be shown by the expression W plus 3. So we can let that expression represent the length of the rectangle in centimeters. And if we were to label our diagram with that information, we would have W on one side and W plus 3 on the other. Now remember that to find the area of a rectangle, we simply multiply the width times the length. So we can use this information to translate the problem into an equation. We would have W times the quantity, W plus 3, equals 108. To solve the equation, we can begin by applying the distributive property on the left-hand side to obtain W squared plus 3W. And now since we see that this is a quadratic equation, we would like to write it in standard form. So let's subtract 108 on both sides. So we have W squared plus 3W minus 108 equals 0. This quadratic equation can be solved by factoring and using the property of zero products. Our two binomials would be W plus 12 and W minus 9. And we can find the solutions by setting each binomial equal to 0. In the first case, if W plus 12 is 0, then W equals negative 12. While this is a valid solution of the quadratic equation, it's not a valid solution of the word problem, since it's unreasonable to have a width that is negative. So from the standpoint of solving the word problem, we can ignore that first solution. On the other hand, if W minus 9 equals 0, then W equals 9, and this is a reasonable solution for the width of the rectangle. So the width is 9 centimeters. And to fully answer the question, we need to give the other dimension as well, which is the length. Well, the length is simply 3 more than the width, so we add 9 plus 3. And we can state that the length of the rectangle is 12 centimeters. Now we fully solved the word problem using a quadratic equation to do so. Let's do one more example. The area of a triangle is 42.5 square inches. If the height is 1 inch less than twice the base, find the base and the height. Round to the nearest tenth if necessary. Again, it might be helpful to make a quick sketch of our triangle. Remember that the base of the triangle and the height of the triangle are perpendicular to each other. Let's define some variables. If we let x equal the length of the base of the triangle in inches, then note that the height is 1 inch less than twice the base. So using x to represent the base, we can write the expression 2x minus 1 to represent the height of the triangle in inches. To calculate the area of a triangle, remember, we multiply 1/2 times the base times the height. We can use this to translate the problem into an equation. 1/2 times x times the quantity 2x minus 1 equals the area, which is 42.5 square inches. To solve the equation, let's apply the distributive property. 1/2 x times 2x is simply x squared, and then 1/2 x times -1. And then let's subtract 42.5 from both sides, so that the right side of the equation is equal to 0. Now to solve this equation, it might be easier if we clear the fraction and the decimal from the left-hand side. So let's multiply both sides of this equation by 2. Now we have 2x squared minus x minus 85 equals 0. That expression on the left-hand side is prime. It cannot be factored. So to solve this equation, we can instead identify the values of a, b, and c and use the quadratic formula. We can see from the equation that a equals 2, b equals -1, and c equals -85. Let's substitute those into the quadratic formula. We have x equals -1 plus or minus the square root of -1 squared minus 4 times 2 times -85 all over 2 times 2. If we do some simplifying further, we have x equals 1 plus or minus the square root of 681 all over 4. Square root of 681 is not a perfect square, but we can approximate it with a decimal. Rounding to the nearest tenth, we would have 1 plus or minus 26.1 over 4. Note that one of those solutions, if we used 1 minus 26.1 in the numerator, would be negative. That's an unreasonable value for the base of this triangle, so we can focus on the positive solution. 1 plus 26.1 over 4 is approximately equal to 6.8. And that's the base of the triangle. To find the height, we then need to take twice the base, 2 times 6.8, and then subtract 1. This gives us 13.6 minus 1, or 12.6. Now let's state the answer to the problem clearly. We can say that for this triangle, the base is 6.8 inches, and the height is 12.6 inches.